So Weichai is an automobile manufacturer. It is based in China, and as you can imagine, a lot of this business involves image analysis. For example, to identify parts in the manufacturing line or to identify problems in the manufacturing line. They also run an insurance business, so they want to make sure that there's no fraudulent claims. So we worked for them for about 1 year. This project actually has concluded. We worked with them for about 1 year to help them process the images with machine learning, for example, to do fraud detection or to do recognition of manufacturing parts in their assembly line. That was that project. And also, as I mentioned, we were collaborating with Takeda Pharmaceuticals, which, as some of your viewers may know, Takeda has a very big collaboration with MIT. It's like an umbrella project that we're part of. It is run by the School of Engineering, and we're helping them to characterize their manufacturing line, in particular to make sure that the mixtures, when they mix to produce the final pills, to make sure that they have exactly the right dryness, so to speak. It's very important to maintain humidity and at an appropriate level. Yeah, so we're helping them optically characterize that. That project is also, it seems that very soon they will start adopting it in their manufacturing line. So we're also very excited. I'm very heavily involved in the Singapore side of things also. So we're talking to a lot of companies, obviously in the biomedical area. I mentioned the glaucoma project that is sort of very close to clinical application. Then the cell manufacturing program that we're collaborating with Professor Van Vliet it also involves a lot of pharmaceutical companies who are interested in cell manufacturing and personalized medicine. I'm also involved in, very recently I was involved in a precision agriculture program also in Singapore. And also we're looking at imaging. I am not really a plant biologist, obviously, and I'm not a cell biologist either, but all of these things require imaging, right? So we have a lot of customers, so to speak. So once again, the agricultural industry is experiencing a renaissance because of vertical farming, eco-friendly farming, urban agriculture. These things are becoming very important these days for a number of reasons. The world is getting urbanized, so it's important for people to perhaps grow groceries in their balcony, right? This kind of idea. So once again, there's a lot of agri companies that we're talking to, and involved in different ways. Some of them were projects, some of them, were discussions. Yeah. As you know, MIT is very good with this pipeline to sort of maintain both the very fundamental research and also be open to talking to companies to see how we can translate it. If there's an imaging problem, especially an imaging problem that seems to have no solution, then come to us, right? I cannot promise that we can solve, obviously we cannot solve every problem, but we're always open to listen, right? Very important to describe to us the actual context. What exactly it is that you try to image? What are the constraints? Can I install a synchrotron in your facility? Most likely I cannot, right? Can I install a tiny laser, which is eye safe and low power? In some cases, yes, right? Well, in some cases, maybe not even that, right? Maybe you can only allow to use a standard, kind of iPhone camera. Yeah, so we need to know all of these things, right? What are the constraints? What are the challenges in the problem? And then we get to start thinking, right? Most of the time, one of the reasons I like this job is that most of the time we also have to learn quite a bit about the domain that we image. I had to learn a little bit about cells before I got involved into that project. And now, because I'm new to this agricultural problem, and I'm reading a lot of papers about plants and about, modern farming. I do not have the aspiration to become an expert in these topics, but I really do enjoy understanding the problems better. That's when we can design imaging solutions that really address the problem, right? So sort of the message is that the science that we're helping the users solve is also helpful to us. If you're a drug manufacturer, I would like to understand how your process works. How are you setting up your mixes, and what are the constraints? What do the regulators say? What are the operating ranges that you're allowed to operate? All of these things we need to know, and they help us to design the imaging systems properly. So it's a lot of fun and also hopefully very useful.